Can you hear me?
Yeah,
Great.
great. Well, I might let you introduce yourself, Dan, if that's okay.
Well, hi everyone. Thanks for inviting me out today. I'm Dan Raichel. I'm the acting director of NRDC's Pollinator Initiative. NRDC stands for the Natural Resources Defense Council. And I've come today to talk a little bit about our work on pollinators and specifically on neonic pesticides. And I'm going to attempt to share my screen here. Hopefully this works. Can folks see my screen now?
Yep.
Yes.
Great. So let's start the slideshow. Oh, here we go. So the presentation I have is called, Birds, Bees, and a Second Silent Spring, a reference to Raichel Carson's work, our work on neonicotinoid pesticides. So yeah, I'm talking about neonics today, but let's start with a little background on the humble honeybee. So as probably most of the folks in this audience know, bees are really important. 1 out of every 3 bites of food that we eat come to us by way of pollinators. Pollinators are responsible for bringing us those foods. And if you actually look at the top 100 crops grown worldwide, about 70+% of those require some form of pollination from pollinators in order for folks to produce those crops. So to give you a sense of what this looks like in the grocery store, some of you may have seen this before, this is what your typical produce aisle in a grocery store looks like with bees, and this is what that same aisle looks like without bees. So certainly without bees, we would not have no food, right? There would still be some food, but we would just have less of it. It would be more expensive, less nutritious across the board, and less of it. Equally as important, bees and other pollinators not only pollinate the foods that we eat, but also whole ecosystems. So about 85% of the world's flowering plants, which is most plants on the face of the earth, requires some form of pollination, either by bees or other insects, by birds, bats, etc., but some form of an animal pollinator to propagate. So if we saw continued losses of pollinators, and bees in particular, we would see not only food insecurity issues and the loss of certain foods, we could see the collapse of ecosystems. And that's kind of what we're worried about, because in the mid-2000s, beekeepers across the country and across the world started to see their losses of honeybee colonies suddenly spike. Before about 2006, those losses were in the 10 to 15% range a year, and those jumped to 30, 40, 50% virtually overnight. Since that time, those losses have persisted at about those levels. US beekeepers report losing about 40% of their colonies across the nation per year. So this has become sort of a troubling new normal. And while there's a whole industry of folks breeding honeybee colonies in queens to replace those losses, so actually colony numbers have remained slightly flat or even a little bit higher since 2006. There is some question as to whether that system is long-term sustainable. At some point it may crack and break. And it also doesn't account for the 4,000 other species of bees that we have here in the United States. Honeybees actually are not native to the United States, but there are 4,000 species that are, and those include, of course, bees of different color, blues and greens. All of these bees are critical to the well-functioning of ecosystems, and we simply don't have the numbers on these wild bees in the way that we do for honeybees. Honeybees are essentially a livestock in the United States. So, we have a relatively accurate sense of how many colonies are out there, how many colonies we're losing per year. we have good data. We just don't have that for most wild bee species, although we have a few examples. Sort of the most notable one is the rusty patch bumblebee. So this was a bee that was pretty widely distributed across the Midwest, especially the upper Midwest and the East Coast. And as recently as the mid-1990s, this would have been one of the most popular bumblebee, one of the most common bumblebee species that you would see outside. Since that time, the bee has lost about 90% of its range and became just recently the first bee in the continental United States on the endangered species list. And certainly it's not the only one that would meet the criteria for that listing. So, as mentioned, these wild bees, these native bees, are incredibly important for ecosystems, but they're also important for crops. More and more, we're learning about the role of native bees in crop pollination. They provide a tremendous amount of sort of free, what's known as pollination services. In some cases, they're more important than honeybees for crop pollination. So, again, the prospect of losing these native pollinators, both a concern for ecosystems and for food production. And certainly where you have, the loss of native bees, that then emerges as a new cost for farmers that have to go and contract to get honeybee pollination or keep bees on their farm. So, what's the problem for bees? Why do we see these losses across the board? And by all means, it's a death of many cuts. There are a lot of problems. Certainly, climate change is a factor. Also, to some extent, monocultural agriculture that doesn't, that sort of eliminates natural habitat, and also urban sprawl that's, in some cases equally as good at destroying good pollinator habitat. You have diseases and parasites. This is a picture of a honeybee with the varroa mite. This is a parasite that only affects honeybees. But certainly, we have higher numbers of honeybee colonies that are succumbing to varroa mite. But last and certainly not least, there's pesticides. And this is one of the key big problems facing bees. And in particular, we have focused our work on one class of pesticides, neonicotinoids, that we think are particularly problematic. So, why do we care about neonics? There are a lot of pesticides out there. What's the big concern with neonics in particular? Well, there are three big things. The first is that neonics are super duper toxic to insects. And to give you a sense of scale here, just one neonic treated corn seed can have enough active ingredient to kill about 250,000 bees or more. And we know that since neonics have been introduced, they have made US agriculture about 48 times more harmful to insect life. And this is from a study that came out in 2019. And if you'll notice, that chart stops at 2014. Neonic use has only increased since then. So we would assume that that chart has continued to grow. But the sort of the harmfulness attributed to neonics is the light blue area, and the dark blue, all other insecticides combined. Second big problem with neonics is that they're really good at contaminating the whole environment. So they're systemic insecticides, which means that they're designed to permeate plants, to get into the leaves, the root, the fruit, the pollen, the nectar, everything. And this means that neonics can be applied in all sorts of interesting ways. Certainly they can be sprayed like older conventional insecticides, but they can also be applied to the roots or painted on a crop seed. And here's what that looks like. And the crop plant, as it's growing, literally soaks up the pesticide coating through its roots and becomes toxic to insects. Again, sort of the whole idea of a systemic insecticide is it makes the plant itself the pesticide. That is not a very efficient way of applying the neonic active ingredient. So only about 2 to 5% makes it into the target crop. Some of the neonics are released as dust, especially if they're in a pneumatic planter. And then the other 94, 95+% stays in soil where it can remain for several years. And those same properties that let the neonics sort of get soaked up into the plant also means that they're really mobile in the environment. They're really water soluble. So anytime there's a rain event, anytime there's irrigation, those neonics are dissolving in the water. They're moving through the soil. They're contaminating new soil. If there are plants in that soil, those plants are soaking up the neonic pesticide. If there are waterways nearby, those waterways are becoming contaminated with neonics. The third problem with neonics is that they're just so darn popular. A lot of people think of neonic use on the farm, and certainly there's a lot of neonic use on the farm. Up to 100% of conventional corn seed is pre-treated with a neonic. Up to about 50% or possibly more, we actually don't have good numbers, of conventional soybean is pre-treated with a neonic. It's becoming more and more common in wheat and cotton, and also specialty crops as well. But that's not the only place you find neonics. Certainly, you find them all over home gardens. Lawn treatments are a big use of neonics in urban areas, commercial landscapes. And actually, in some areas, some urban and suburban areas, we actually find higher levels of neonics in waterways than we do in rural areas. So it just shows you, how widespread the use of these products is. And this gives you just a little bit of a sense of that. So this is just ag uses for one neonic, imidacloprid. There are 5 main neonics that are approved in the US. So this would be much more filled in if we counted all 5. And this doesn't count urban and suburban uses. So a lot of those white areas and urban areas would be filled in if we counted those uses. And I know 2009 isn't horribly recent, but all the trends we've seen suggest that neonic use is as great or greater than it was in 2009. So, the sum total result of this is that there are places in the country where neonic contamination is just virtually ubiquitous in soil and water and plant life. And that has an impact. And we know now, there was some question maybe in 2006, but now there's just an overwhelming body of scientific research linking neonic use to bee losses. And again, those are we see it most visibly with honeybees, about 40% a year, but certainly the concern that they're the canary in the coal mine for the nation's 4,000 plus wild bee species. We also are learning increasingly that neonics are associated with other harms outside of the bee world. They kill birds, for instance, and this sort of happens in 2 ways. Birds do eat neonic-coated seeds, and one neonic-coated seed has enough active ingredient to kill a small songbird. For larger birds, they can die if they eat enough seeds, or they can become disoriented, and it can affect their migration patterns in ways that affect their survival. And there's also, with a widespread neonic contamination, we also have a lot fewer bugs in the terrestrial environments. And as it turns out, birds eat bugs. So if you have fewer bugs, you have fewer birds. And there's good studies linking that in the Netherlands and France, and also a really good study that came out here in the US last year, sort of more definitively linking neonic use to the decline in bird biodiversity right here in the United States, particularly insect-eating and grassland birds. Another big problem with neonics is that they affect fish populations, sort of in the same, not as much directly as with birds, but certainly those same effects where when neonics contaminate a waterway, which they often do, they're really toxic to invertebrate life. So they wipe out communities of invertebrates, water bugs, and fish eat those bugs. So there was a good study in Japan that showed that the introduction of neonics in nearby agriculture virtually wiped out a sustainable fishery within the course of a year. And for that same reason, the neonics came into the water, they wiped out the bugs, and then the fish that ate the bugs, also their populations also plummeted. Last but certainly not least, neonics are all over food and water. Certainly surface waters across the US. Unclear how much of our drinking water is contaminated, although there was a good study in Iowa finding that at least one university water supply at the University of Iowa was ubiquitously contaminated with neonics. Neonics are also pervasive in food. A lot of studies out showing, that foods contain levels of neonics in them. And, it's not like your grandfather's pesticide, right? These are not, when neonics are treating a plant, they pervade the plant. So you can't, if you have a neonic, an apple that's been treated with neonics, you can't wash that off. That's actually, the neonics are in the apple. So much more of a concern for human exposure. And sort of the proof is in the pudding. Centers for Disease Control did an update to their biomonitoring study last year, or maybe it was 2019, that found that half the US population is regularly exposed to neonics. And sort of the evidence of that is the neonics or their breakdown products appearing in people's urine. And that's a scary thought, because neonics are increasingly being linked to the risk of developmental and neurological damage in people. And so that science continues to develop, and those concerns continue to develop. This is a slide I used from our New York work, but this just gives you a sense of sort of water contamination across the country. These results are fairly similar in other places. Usually in any given water survey, about half of surface waters you find neonics in, and in most of the cases, those are at levels that are above EPA's benchmark for harm to aquatic invertebrates. Again, those bugs that make up the base of aquatic ecosystems. So if you lose those, you start to see ecosystem damage. So this is just a fairly common and pervasive issue now in the US. And so, add it all up, and people begin to sort of link neonics to a second silent spring. And this is Raichel Carson's 1960s book on pesticides, imagining a spring where there's no bird song, no bugs buzzing, and with also impacts to human health. And when I first started working on this issue about 4 or 5 years ago, I thought the whole second silent spring thing was a little overblown, but we really do keep getting a new study about every 2 weeks or 3 weeks that point to the massive ecological damage that neonics are causing. They are sort of hollowing out the environment in front of our eyes. And I think a lot of us don't see it, which is kind of interesting. Although one anecdote that I've heard from entomologists is sort of the windscreen test. Like, if you remember, for those of us who were around in the 80s and the 90s, if you drive through a rural area, you'd get a lot of bugs on your windshield in the summertime, so much so that you'd have to use your windshield wipers. And that is less and less of a common experience these days. So, what have other jurisdictions done across the world? EU has banned all outdoor use of the most popular neonic chemicals. In Canada, and EU did that to protect pollinators. Canada is moving to do the same, and they're expected to issue, I think, a final decision sometime this year, although there's some sense maybe they're getting cold feet. But they had at least proposed doing the same to protect aquatic ecosystems. So it's interesting, 2 countries or 2 nations deciding to take sort of the same course, but for different reasons. France has banned outdoor use of all neonic chemicals. So those are the big 3, imidacloprid, clothianide, and thiamethoxam, in addition to acetamiprid and dinotefuran. Here in the United States, there's been very little done. EPA has recognized a lot of the same risks. If you look at their risk assessment documents, they know all of this stuff is going on. It's no secret. But when EPA proposed sort of a decision on sort of the continued use of neonics, it's called a registration review decision. It was released this year. They basically approved business as usual, continued widespread use of these pesticides. And we know the problem with neonics is not misuse of neonics. It's not people that are using neonics in ways that are not approved on the label. It's those approved uses that are dangerous to bees and to ecosystems and potentially to people. We also know that, and we don't have to get into the weeds here, but when EPA approved or proposed those decisions, it was sort of calculating the risk in a way that we feel violates federal law, particularly federal law that's designed to protect people, in particular pregnant women and children. One other interesting thing about what's done at sort of the federal level, there's also been no regulation of neonic-treated seeds and other pesticide-treated seeds as pesticides. They're actually exempt from FIFRA, and that's due to a loophole created by US EPA. And I don't know if any of you have seen sort of the story recently, but one of the impacts of this loophole is that an operator in Mead, Nebraska, an ethanol plant operator, I should say, decided to use neonic-treated seeds, or to be sort of the key operator using neonic-treated seeds to create ethanol. And that resulted in sort of these toxic waste streams being created by the process, and that's caused all sorts of environmental problems in the Mead, Nebraska area. Actually, after this story broke, the Nebraska legislature took up a bill to sort of stop this from happening in Nebraska. I'm not sure whether that bill will pass or not, but certainly even if the bill passes in Nebraska, that's not going to stop an operator in any other state from accepting these seeds. And that likely will be a risk until either every state takes action or until EPA closes that loophole. And I'll go back one slide here just to talk about what's done in the states. A few states have made neonics restricted use pesticides, which means only certified applicators, licensed applicators can apply them. But in practice, this is not going to restrict most neonic use, because the vast majority of neonic use is either happening on these treated seeds or it's being applied by certified applicators. And again, it's not misuse of neonics that's the problem. It's the legally approved use by EPA that is problematic. So, what is NRDC doing about all this? We're doing a lot of litigation, and I think I may not touch on that unless folks have specific questions. I think I'd like to just talk about some of our state campaign work. And, we're focused right now on 3 states. So in New York, and actually those bill numbers are old, that's from last session. In New York, we're working on a bill that would, initially we were working on a bill that would be a 5-year moratorium, but didn't include neonic-treated seeds, which we know now is about 3/4 of the agricultural use of neonics in New York. So a big chunk of the pie. This session, we're trying to get a bill introduced that has permanent bans, but is a little bit more targeted. It doesn't have this across the board ban, but it focuses on 3 problem areas associated by, 3 problem areas identified by a new massive report from Cornell University. So this is a report that came out this summer. It looked at 1,100 plus peer-reviewed papers, basically everything that's been written on neonics and pollinators and neonic uses versus alternatives. And it was basically this huge cost-benefit analysis of neonic use. And what the report found is treated corn, soybean, and wheat seeds, which is the largest single use of neonics across the country, may account for the vast majority of neonics used in the country. Those treated corn, soybean, and wheat seeds pose substantial risk to pollinators. but they provide no net income benefits to farmers, no overall net income benefits. And to break that down a little bit more, neonic treated corn, soybean, and wheat seeds rarely provide yield benefits for farmers. And even in those cases where they do, if you look at the additional cost of having the neonic on the seed, it's a wash. The second big conclusion of the Cornell report is that outdoor non-agricultural uses, non-farm uses, so think golf courses, home gardens, lawns, etc. Those uses are mostly not needed. And even when they are, there are safer alternatives that are available. The big exception there is invasive species treatment, which the report identifies as an important treatment. And then, third, there are other sort of needless uses of neonics. And a lot of this depends on particular chemicals. Some neonics are more persistent, more toxic than others. So, there may be a need to, or the ability to switch to sort of the less toxic uses and have less impact on the environment with sort of the same effectiveness. So all that said, we're working on a bill, again, that's sort of targeted around these findings. One that bans the use of these neonic-treated corn, soybean, and wheat seeds because they're not providing a benefit, and by far they are sort of the largest offender when it comes to environmental contamination. And it's worth noting here too that neonics were around since the mid-90s, but it wasn't until the mid-2000s that we started seeing bee colonies dying en masse. And that's about the same time that you see neonic treated seed take off, right? Particularly corn and soybean. So there's a sense that those seeds are very much associated with the bee crisis. The bill also targets or would target those outdoor non-farm uses with the exception of invasive species, and then have put the onus on the state pesticide agency to address other needless uses. New Jersey, we're doing sort of the same thing. We're working on a bill, trying to advance a bill that would prohibit those outdoor non-agricultural uses. So basically everything in the New York bill except for the treated seeds. And in New Jersey, that would be really impactful because New Jersey doesn't have a lot of corn and soy, is mostly, pollinator dependent agriculture, and also has a ton of urban and suburban areas. So actually the vast majority of neonic use in New Jersey is in those non-farm uses. And in California, we're doing two things. One, we are pushing the State Department of Pesticide Regulation to, in their rulemaking of neonics, they're doing a neonic rulemaking now to sort of have the toughest, most stringent standards, both for agricultural use. And this doesn't say this, but where the rulemaking now doesn't include non-ag uses, and it doesn't include treated seeds, which again, we think are sort of the two biggest components. If you add up those two, you probably get in any given state, 80+% of the neonics going into the environment. And, again, those are uses that are not justified, right? They're either not providing benefits to users, or they're easily replaced with safer alternatives. The other thing we're trying to do in California is we're trying to get California to close this treated seed loophole that EPA has created. EPA created the loophole at the federal level, but any given state has its own pesticide laws. And we think California law requires the agency not just, it doesn't just give the agency authority to regulate neonic treated seeds, that the law actually demands that the agency do that. And California, being the big agricultural behemoth that it is, if DPR were to take steps towards regulating neonic treated seeds, that might push EPA to finally close the treated seed loophole. It might also provide a framework for other states to, short of EPA closing the loophole, to take their own actions and regulate those seeds once, California's sort of blazed the path. So that's all I have. I know that's a lot of information. I wanted to leave some time for questions. So yeah, do folks have any? And maybe I can stop the share here and go back to
Yes, thank you so much, Dan. That was just fantastic. Very, very informative. And we have been getting some questions in the chat. And so Caitlin is going to read those off.
Great. So first from Jeanette, we have, what are some brands of neonics?
That's a good question. So, the neonic chemical names themselves are imidacloprid, acetamiprid, dinotefuran, thiamethoxam, and clothianidin. And a lot of times they're sold under the brand names. I mean, it would depend on what crop you're talking about. On the consumer side, they were sold for a while as Bayer Advanced. I think that got changed to Bio Advanced, but there's all sorts. Neonics are out of patent now. They're all out of patent. So there's so many different consumer products. They're also in pet products and indoor bed products as well. In the agricultural side, some of the brand names include Gaucho and Poncho. I forget, I can't believe I'm blanking on what Syngenta's brand name is. They're sold under the Farmore brand, although not all Farmore treatments contain neonics. So even within certain brands, some of those are going to contain neonics and some of those don't. And I can't believe I'm blanking on the Syngenta brand name for neonics, but they're sold under a number of brand names. If you want to know, if you want to find a good listing of those brand names, I think University of Wisconsin has a good resource called What's on My Seed, and it has all of that listed, including the chemical and the brand names.
Great, thank you. Next, we have Margaret Stewart asking, are any elected officials carrying the banner for control or ban of neonics?
I assume you mean at the federal level rather than the state level. So certainly in all those states, there are legislative champions. But at the federal level, there are two bills that were introduced last Congress that would ban neonics in some form or another. And those were Saving America's Pollinators Act, introduced by Representative Blumenauer out of Oregon. And then there is also the Protecting America's Children from Toxic Pesticides Act. And the sponsors there were Senator Udall, who's no longer in office, and House Member Neguse.
Okay, great, thank you. And next we have Connie Bonfi asking, I'm wondering if we have research on neonics' impact on livestock or family pets.
Oh, that's a good question. I wish I had my health expert on. So a lot of the people poisoning incidents related to neonics stem from pet collars. So they're actually pretty extensively used in pet collars. And I believe there are some pet poisoning incidents. Don't quote me on that. I actually don't know that literature as well. I don't know about livestock, but what I do know is that there was a good study that came out of South Dakota linking low levels, sort of they call it field realistic levels of neonics in water, stuff that you'd expect to see in the environment, with developmental defects, birth defects in white-tailed deer. And that's a pretty scary study because, white-tailed deer are large mammals, we're large mammals. I don't know of any in livestock in particular, unless of course you count, bees as livestock, then certainly.
Great, thank you. Next I have, how can we test for neonics in our creek? Again, from Margaret Stewart.
That's a good question. So neonic testing, I think historically has been reasonably expensive. I know Cornell got a machine to do neonic testing, and that's something that I think certain universities, and I think Cornell offers this service too, will do contract testing. And I forget what the going rate is. I think it's like $100 a sample. something in that range, which if you can believe it is actually kind of cheap. And that's for all the neonics. But I assume the testing prices will come down, but it's something that's still in sort of the moderately expensive range.
Great, thank you. Along with restricting use, are you suggesting alternative to control insects, like improving the soil with organic matter, microorganisms, and other soil health improvement methods?
Totally. I mean, that's the other side of the equation. I mean, so in a past life, I worked on fracking. I fought fracking in New York and leading up to the ban there in 2014. And the flip side was, what are you going to do if you don't frack? What are you going to do for energy? What are you going to do for jobs? And the answer there was renewable energy, right? There's a lot of jobs in renewable energy. There's money in it. And it's better for the planet from a climate change perspective. And I think, this issue is similar as, well, what are you going to use if you don't use neonics? And I think, we actually have one sort of better answer here sort of initially, which is the number one use of neonics doesn't make any sense, right? It's on these corn, soybean, and wheat seeds that farmers are paying for. These are additional input costs, and they're not getting benefits, right? So, immediately we could replace neonics, or at least this largest use of neonics, with nothing, and we would all be better off. But I think beyond that, certainly, the answer here for neonic use and pesticide use in general is we need to find ways of growing food and that sort of harness the natural powers of nature to address pest problems, or to structure it in ways where we would not need to use pesticides. That's the real long-term answer here. Because certainly neonics are not going to be the last pesticide that come out from the chemical industry. And indeed, there are replacements that some of which the chemical industry has released and some of which are, I'm sure, in the pipeline. But ultimately, any sort of pesticide is designed to kill or harm life. And we need to figure out a way that we reduce that use overall.
Great, thank you. From Dale Beams, we have, are there neonic immune pollinators?
I think when you look across the spectrum, I don't know if immune is the right word, but I think there are certainly pollinators that are likely less susceptible. The toxicity varies. Again, 4,000 species of bees, and that's just bees. Right? That's not including butterflies. That's not including flies and wasps or birds and bats. All of those are pollinators. So I think there are different susceptibilities among those species. It's variable. I think it depends on what type of use you're talking about. Sometimes the way in which neonics are used. There are 5 neonic chemicals. So each of them have sort of varying levels of toxicity, and that's going to depend on the species. So when you dig down into the weeds of it, it gets complicated, but the underlying fact is that these are neurotoxic pesticides, and they affect insects, they affect insect nerves, they affect nerves in other animals, invertebrate animals. That's going to vary, but to some degree, they have effects across the board. And I guess the last thought there is, the only fully immune pollinator I would assume in my mind is one that we create. And there is actually talk about creating robot bees or pollinating with drones. Certainly some sort of mechanical solution would be immune from neonics because, machines aren't alive in that sense.
Great, thank you. This next question from Christine, this might be more relevant to some of the folks at the Kansas Rural Center because this might be a state specific to Kansas question. What kind of discussion is there on the state level for restriction of pesticides, specifically neonics?
I don't know about Kansas at all, unfortunately.
Yeah, I could probably jump in there. I don't think to my knowledge, there has been no discussion about banning the use of neonics or really any other pesticides that I'm aware of. The way we try to sort of get the ball rolling on that is to jump on any legislation that has anything to do with pesticides. So for example, counties spraying their ditches and that kind of thing, we try to really get in and advocate, against using pesticides as much as possible. And definitely in the last few years, there's been, they've tried to kind of expand the authority of the Department of Ag to be able to label noxious weeds as, an emergency and stuff. So we try to do anything we can, and people working on the issues in Kansas to just limit it. But it would be a tough sell to or a tough row to hoe to start down that road in Kansas. But for sure, we should all, work on it. I mean,
yeah, and it's funny and right. I think in terms of identifying the states that we work in, we're identifying states where we think change is politically possible, and that right now is New York, California, and New Jersey. But certainly the arguments here, I think, are real strong for farmers. If I was a sort of a pollinator-dependent farmer, I would be upset about my neighbor's use of neonics, particularly if it was wasteful. I know in Kansas, maybe the dominant crops are less sort of the fruits and veggies and more corn and soy. But even then, these are input costs, and granted, they're relatively small input costs in the grand scheme of things, but these are input costs that aren't providing benefits. And there are studies that show, beyond just like not providing a benefit, they could be detrimental when you're talking about beneficial insects, right? The predators of these pests. In some ways, neonics are sort of, they're self-perpetuating their own need because they have impacts on these beneficial insects that are sometimes, stronger than against the pests, right? Because the predators eat all of these pest insects that have neonics in them, so they get greater concentrations of the neonics and they die out more quickly. So in a sort of an odd way, by killing all of those beneficial insects, they may create a greater need for them to address pest issues. And again, it's, going back to the question about natural solutions, that's really the future, right? And having the environment ubiquitously contaminated with a neurotoxic pesticide is fundamentally opposed to those sorts of solutions, right? Especially when, right, the science just doesn't support that it's useful.
Great, thank you. This question is specifically about mosquito spraying, and how far does that spread out from where it is being sprayed, realizing that winds play a part in this?
So I don't know anything about mosquito spraying. Neonics, to my knowledge, are typically not used in mosquito spraying. Again, this is sort of goes back to the nature of how they work. Neonics are designed to get at plant eating insects because they're designed to pervade plants and then make those plants poisonous. So for insects that are carnivorous, right, that eat blood or other insects, neonics, I think, are not the insecticide of choice. So that's true for mosquitoes, that's true for ticks. I could be wrong, there may be some mosquito treatments, but I think, neonics are sort of these long-term poisons that are meant to persist and sort of, provide control over time versus sort of the old-fashioned, like, kill the bugs really quick type of poison, which I think probably, you would use in a mosquito application.
Great. This next question from Becky Tipton. Some of the big box stores, Lowe's and Walmart, pledged to remove neonics from their plants. This was years ago. Has this actually happened? Are these plants safe for planting for pollinators?
So that's a very good question. And I think, again, the answer there is probably complicated. And Friends of the Earth did a really good campaign. We participated in that campaign to get these concessions from big box retailers. I actually looked, so that if you look at the promises they made, some of them are stronger than others. And at the time, I don't believe they applied to their online stores. So if you go to some of these retailers and you just type in like a neonic chemical, right? You type in imidacloprid or something like that, you'll find that a number of these stores are still selling those products. And I don't know how that translates to their plant offerings, frankly, and I just don't think we have good information on that. But if they're, if the fact that they're still selling these neonic products on their websites is any indication, my guess is that it hasn't been a high priority for the company. And again, that's going to vary by retailer, but I think there's been, the follow through there has left something to be desired.
Thank you. And I know you spoke of this a little bit earlier, but we have another question about water treatment plants for drinking water. Do they remove neonics?
So very good question. And again, the answer is it depends. So that study I mentioned in Iowa, that was actually done by USGS scientists. And one part of the study that they looked at was, does your classic chlorination treatment remove neonics from a water supply? And the answer was, in the main, no. And that's why you saw, University of Iowa water sort of ubiquitously contaminated with neonics, because they were using one of these older chlorination plants. And I think that's probably, I'm not an expert on water infrastructure, but my guess would be that it's probably more common in rural areas that you have these older plants that are using the chlorination system that doesn't remove the neonics from the water supply. I do know that sort of for more modern plants that use not only chlorination, but additional filtration, I think in specific carbon filtration, that is pretty good at removing neonics. But yeah, it's just going to depend where you get your water from, what sort of water is going into that plant, what sort of system they use. And I think for groundwater too, if you're pulling from an area that has neonic contaminated groundwater, right, that's not going through a treatment plant. So that's going to be a concern too. And I think that's also, going to be more common in rural areas.
Great, thank you.
I do know there was a few years ago, they found neonics in the water supply, Iowa City, which for us feels fairly urban. But anyway, so that's not a good sign. So I don't know if they've, treated it since, but anyways.
Okay, the next question from Margaret Stewart. Several years ago in Kansas, we had a hard time getting non-neonic treated seeds. Has the supply of untreated seeds improved?
I don't think at all. I could be wrong about that, but to my understanding, I think maybe there's, maybe been some more availability because this has been an issue that's been in the public mind, but I think it's marginal. Certainly there's organic seed, which wouldn't have neonics, but in terms of the conventional areas, there actually is Ecdysis that has a website that's, I'm trying to spell it, ECDYSIS, had a website, I haven't checked it recently, where you could look for suppliers of seed that didn't contain neonics for these field crops. And that included both conventional and organic seed. But I think it remains very, very small. For the most part, for corn seed, almost always that seed is going to be pre-treated with a neonic. And if anything, my understanding that it's become more popular to apply neonics to other field crop seeds as well as in addition to specialty crops.
Mm-hmm. Lucinda, are you, Lucinda replied in the chat. Can you unmute and answer? She's a farmer and had a little expertise on the seed issue.
It's extremely difficult to obtain seed that has not been treated. and they start treating the seed after they receive it from harvest. So you really have to order it way ahead of time. And so that's, you know, it's possible, but it's also very hard to get. A few companies now are treating the seed just before they deliver it, and those are the ones that you want to patronize because they don't treat the seed until you order it, because there's so many different treatments that you can put on the seed. So we're making some headway, but not nearly fast enough.
I know that, thank you so much, Lucinda. I know that Albert Lee Seed in Minnesota has done a lot of work in trying to bring in more seeds that are not treated and sort of help propagate that whole thing. But I don't know how that works, you know, if you're in Kansas and trying to get it. And that ecdysis that Dan mentioned, that is Dr. Jonathan Lundgren's research company that he founded. He's spoken a few times at our conferences, so some people here are familiar with him. So yeah, that would be a great resource.
And he also did that great deer study. So
Yes.
yeah, he does a lot of great work.
Great. I think we have one more question in the chat. Is there any evidence that neonics affect the microbes in the soil?
So that's a really good question. There are some studies that show neonics have an impact on microbial communities. This is a really nascent area, and it's soil science is not my expertise. You know, I'm an attorney and originally was an English major, but in soil science, I mean, I sort of get a lot of the toxic stuff, but soil science is sort of next level. But yeah, I think there is an impact, and how, you know, whether we would characterize that impact as beneficial, not beneficial, or neutral, I think there's still a lot of gaps there, but we do know that neonics do affect soil microbial communities. They suppress certain microbes, and they also encourage the microbes, unsurprisingly, that break down neonics, right, that eat the neonics. And I think there is an open question now. I actually talked with one of the researchers who's doing some of this research, and she said, you know, it's sort of thought that all neonics sort of break down and disappear, but I guess it's not quite clear that all of the breakdown products of neonics ultimately disappear. And some of those breakdown products can be more toxic to people. So again, going back to that study in Iowa, it's actually interesting that as neonics went through sort of the chlorination treatment, these chlorine atoms would sort of glom on to the neonic breakdown products and form other products that you would assume would be much more toxic to people. Some of the neonic breakdown products on their own are about 300 plus more times toxic to people. And then of course you're adding a chlorine atom, which could further, you know, increase the toxicity. So that's the water treatment system. But again, there's sort of this question about what is the true fate of neonics and all of their breakdown products in the environment, and how that affects soil microbe communities.
I just wanted to chime in. We got a message from Shirley in the chat that that they farm and ranch, and that the coating has been on the seed since she was a little girl, and that they have had ovarian cysts in our heifers after they started using ethanol byproducts. So they no longer do that. So that kind of goes back to that question about the livestock.
Yeah, and the Mead facility, it's really, I mean, if you read about what's happening in Mead, that I mean, it's criminal, both sort of figuratively and probably literally as well. You know, the feedstock, after it went through the ethanol product, sort of one of the waste products are these wet cakes, sort of like the spent mash from making the ethanol. And if you look at the neonic levels in these, they're just off the charts. And I think initially the company tried to sell those wet cakes as feed, and I think there were issues with like a number of cattle getting sick or dying, so they were forced to stop doing that. But really sort of shameless, and you know, that's just one facility, and certainly meat is sort of the most egregious actor here, because they're really just making it out of the treated seed, so it's super concentrated. But I wouldn't be surprised if, you know, ethanol byproducts from other facilities also have levels of neonics, and also all of the other pesticides, right? Because it's not just neonics that are on the seed, it's not just neonics that are being used in the field. I mean, we've seen over the past 20, 30 years, the amount of pesticides, the number of pesticides and the types of pesticides that are being used just increase pretty substantially. And that trend only seems to continue, right? As soon as a pest develops resistance to one type of insecticide or herbicide, they keep that herbicide, right? And they just add a new one. And that seems to be the path that we're on now. And it's not a sustainable one or a healthy one.
Yeah, I was on a call 2 days ago about that mead plant, and it was, as Dan mentioned, they first fed them as cakes, and then I think after that, if I understand correctly, they then said, well, we can't do that, so they started applying it as a soil treatment, which really is stomach turning also, and they were applying it at, I think it was 18 times the allowable level, and the readings they were getting, I can't remember if it was in the lagoons or some kind of water nearby, coming up at 5,000 times the limit. So really extraordinary, like, misuse of those. So
yeah, I'd say oftentimes with neonics, especially when we're talking about, you know, outside of the insect world, we're talking about long-term chronic impacts. Like, what's the effect of being constantly exposed to a neurotoxin? That's not going to kill us immediately. It's not going to make us sick, but we're just continually exposed to it over a period of decades. You know, it's sort of like one big science experiment. What's going on with that? But mead is the first situation where I've seen, if you just look at the levels there, I'd be afraid today. You know, that stuff is off the charts. I feel really, my heart goes out to folks in that community.
I guess they had a hearing about it maybe 2 days ago, and there was no testimony in favor of it whatsoever, which was, and actually the sort of grandfather of the ethanol movement spoke strongly against, you know, putting a stop to using those seeds. So, so that is one way that, you know, perhaps if legislation gets going in Nebraska around neonicotinoids, you know, perhaps Kansas could then glom onto that at some point. So. Yeah. Okay, do we have any more questions, Caitlin?
No, we don't.
Well, we're just about at our time limit. I just want to thank you so much, Dan, for a phenomenal presentation and answering our questions. We just appreciate your time and expertise so incredibly much.
Well, it's my pleasure entirely. Thanks for inviting me out. Hope the rest of the day's programs go really well. And yeah, thanks again. It was a lot of fun.
All right. Thank you.
Bye all.
Thanks a lot.
So our next session will start in about 15 minutes, and you can find your links to join that in the HUVA agenda, or if you have any problems with that, please let us know. So we'll end it here and see you in 15.
Thank you.